All right, so we've already looked at all of the ways that you can solve systems of equations. We've had graphing, substitution, and elimination. And today we're going to look at one system and do all three and kind of pull all of our methods together to see what they tell us. So we'll start with graphing, and our system is 6x minus 2y equals negative 6, and y equals x plus 1. So if we're going to graph, we have a few options here. We can either find the x and y intercepts of this first one, or we can convert to slope-intercept form. I'm going to try to convert slope-intercept form. So I'm going to rewrite this down here. 6x minus 2y equals negative 6. So I want to get y alone on the left, so I will subtract 6x from both sides. And I get negative 2y equals negative 6x minus 6. Divide by negative 2. And I see that I have y equals 3x plus 3, because I have a negative divided by a negative. So y equals 3x plus 3 looks like this. We find the y-intercept, which is 3 on our graph, so right here. And we know our slope is also 3, so we can go, and we might want to go backwards here and down. So we'll go back 1 and down 1, 2, 3, over 1, 1, 2, 3, and now I can make my first line. Go through that point. All right, so now we can graph our second line, and I'll do it in green. So this one is y equals x plus 1, so we already have it in slope-intercept form. My y-intercept is 1, so I'll find it here, and my slope is also 1. So I can go up and over 1, up and over 1, or to the left and down 1, to the left and down 1, and I can connect all these points to make my second line. And then, to find my solution, I can identify my intersection point, which happens to be at negative 1, 0. So our solution is negative 1, 0. Easy enough with graphing, but let's see what it looks like when we do it with substitution and elimination. All right, moving on to substitution. So in substitution, we want to either know what x or y equals, so that we can plug that into one of our other equations. So I see that I have my second equation, which is y equals x plus 1. So when I see that, I can tell myself every time I see a y, I'm just going to plug in x plus 1. So let's take this first equation and plug what we know in for y. So I'll get 6x minus 2y equals negative 6. And every time I see a y, so right here, I'm going to plug in what I know. So I'll get 6x minus 2 times x plus 1 equals negative 6. I'm going to have to do a little distribution here. Keep in mind that this negative goes with the 2. So I get 6x minus 2x minus 2 times 1. So minus 2 equals negative 6. I can combine like terms over here, and I'll get 4x minus 2 equals negative 6. Add 2 to both sides. And I get 4x equals negative 4. Divide by 4, and I see that x equals negative 1. All right, so I get that x equals negative 1. Now I can use this and plug it into one of my equations to solve for y. So I'm going to bring this guy over here, and I probably want to use this equation because this is already in the form y equals something. So when I plug it in, I should get y equals a number. So I'll use what I know, y equals, and every time I see an x, I'm going to plug in negative 1. So y equals negative 1 plus 1. And negative 1 plus 1 is 0. So y equals 0. And that means my solution is going to be negative 1, 0. And if you remember from graphing, we had that solution as well. Now, I just want to touch on the point. This solution means that these two coordinates, this x and y coordinate, work for both equations. Now, both equations don't always meet up at the same x and y coordinates. In fact, they only meet up at this 1. So when x is negative 1 and y is 0, we're going to get the same answer for both of these equations. All right, let's move on to elimination. Okay, so our key with elimination is to line all of our variables up so that we can eliminate one of them. So when I look at these two equations as they are, I see that I have this one in standard form, But my next one is in slope-intercept form. So my x's and y's and my equal sign are not matched up. So the first step I'm going to do is to write it in a form that can help me. So I'm going to write 6x minus 2y equals negative 6. But then for the second one, I'm going to subtract x so that I have it on the left. So I have negative x plus y equals 1. Now I can see that my x's, my y's, and my equal sign are all lined up, so I'm good to go. Now I have to figure out what I can cancel. So I have a couple choices. I can either multiply the bottom by 6, and my x's will cancel, or I can multiply my bottom by 2, and when I add these two together, the y's will cancel. So maybe I'll just multiply by 6. So I multiply by 6, and I'll rewrite this whole thing below. 6x minus 2y equals negative 6, and I'll get that this is negative 6x plus 6y equals, and I have to multiply everything, so equals 6. And now I can add these two together, and hopefully my x's will cancel. So I'll add, and in fact my x's do cancel, 6 plus negative 6, so I get 0x. Negative 2 plus 6y is going to be plus 4y equals negative 6 plus 6, which is 0. So I get 4y equals 0, so I know y equals 0, because I can divide by 4 and find that 0 divided by 4 is 0. So y equals 0. Now, much like before, I can use this and plug it into one of my equations to solve for x. So I'll bring this over here, and I can use whichever equation I want. I'm just going to use the second one. So I'll get y, and every time I see a y, I'm going to plug in 0. So 0 equals x plus 1. Subtract 1 from both sides because now I'm solving for x. So I get that x equals negative 1. Negative 1 equals x. And that means my solution is negative 1, 0, which is perfect because that's what we got by graphing and substitution as well. So it's always a good idea to check your answer with one of the other methods because you might find that you made an arithmetic error somewhere. You also might decide that one method is preferred over another. If we know that both of our equations are in standard form, like they were here, or almost, we can easily use elimination. But if we know both of our equations are in slope-intercept form, it might be easier to graph. So you kind of have to do a little deciding of which method you want to use. So it's entirely up to you. All right. Next time we'll look at some applications of systems of equations, and I'll leave you to try the problems at the bottom of your guided notes.